Welcome to EduRev. All right, let's talk about geometry in the UCAT Quantitative Reasoning section. If that word alone makes you a little nervous, hey, you're definitely not alone. But don't you worry, because today we're going to build a mental toolkit together, piece by piece. The goal? To help you crush these problems with speed and confidence.
So glad you're here. Let's get you ready to turn those tricky shape questions into easy points on the board. Okay, first things first. Before we can even think about solving these problems, we've got to understand exactly why they can feel so tricky on the UCAT in the first place. So be honest. Does seeing a weird, kind of unfamiliar shape pop up on the screen make your heart beat just a little bit faster? Yeah? Well, if it does, stick with me. I promise by the end of this, you're going to start seeing those shapes as opportunities, not threats. And here it is. This is the single biggest reason for that anxiety. See, unlike a lot of other tests, the UCAT gives you no formula sheet. Yep, zero, nada. Everything, and I mean everything, has to be in your head ready to go. That's a ton of pressure, right? Which is exactly why we're going to build that toolkit right now, starting with the absolute must-know basics.
All right, let's get to it. Let's start building out that toolkit. We're going to begin with the fundamental 2D shapes. You know, the building blocks for pretty much every complex geometry problem you're ever going to face.
First up, circles. You know, the beautiful thing about them is how simple they actually are. Every single thing you could possibly need to know about a circle, its area, the distance around it, the whole shebang, it all comes from just one number, the radius. We just call it r.
So here they are, the three core formulas you absolutely, positively have to know. And just look, see how r is in every single one of them? The diameter, that's the line straight across, so of course it's just 2 radii, or 2r. The circumference, that's the path all the way around the edge, right? That's 2 pi r. And the area, all the space inside, that's pi r squared. Think of them like a family, all connected back to r. Oh, and of course, don't forget a full circle is 360 degrees. Super important for any pie chart question.
And here's a quick pro tip on using pi. This is important. Always check the question. If it doesn't give you a value, you're going to use 3.14. But, and this is a big but, if it tells you to use 3.1 or even just 3 for a quick estimate, you have to use their number. It's a really common trap they set to catch you out, so just be aware of that.
Okay, next up in our toolkit, rectangles and squares. And trust me, you are going to see these everywhere in the QR section. They are by far the most common four-sided shapes, so getting super comfortable with them is, well, it's non-negotiable.
Okay, so for any rectangle, the perimeter is simple, right? It's just the length of all 4 sides added up. So that's 2 lengths and 2 widths. The area, even easier, just length times width. And a square? Well, a square is really just a special kind of rectangle where all the sides are equal. So its area is just side times side, or, s squared. These might seem basic, but I'm telling you, they are the foundation for so many UCAT problems.
All right, let's talk triangles. These guys are incredibly versatile. You'll definitely find them on their own, but honestly, more often than not, you're going to find them hidden inside other more complex shapes. Learning to spot them is a critical skill we're going to work on.
So here are the 2 must-knows for triangles. Perimeter is easy peasy. You just add up the lengths of the 3 sides, a plus b plus c. Now for the area, you have to remember this. It's always 1/2 times the base times the, and this is the key part, the perpendicular height. That means the height that makes a perfect 90-degree angle with the base. That little detail is absolutely crucial.
And now, a squared plus b squared equals c squared. Yep, Pythagoras' theorem. This thing gets its own moment in the spotlight because it is a total lifesaver. For any triangle that has a right angle, this always works. The squares of the 2 shorter sides will always add up to the square of the longest side, which is called the hypotenuse. I'm telling you, this formula will pop up when you least expect it, so please make sure it's locked and loaded in your memory.
Okay, so we've got our basic tools, right? We've got circles, rectangles, triangles. Now let's put them to work on those weird composite shapes that the UCAT just loves to throw at you.
Look, the strategy for any of these intimidating-looking polygons is always the same, and it's a simple 3-step process. Ready? Step 1, you break it down. You find the simple shapes we just covered. Rectangles, triangles, maybe a semicircle hiding in there. Step 2, you calculate the area of each of those simple parts one by one. And step 3, you just add them all up. That's it. That's how you tame a complex shape.
Fantastic. You're now comfortable with 2D shapes. So let's level up, shall we? We're going to apply the exact same kind of thinking, but now in 3 dimensions. We're talking volume and surface area.
Okay, here are your key 3D volume formulas. But listen, instead of just trying to brute force memorize them, let's look for the pattern. It makes it so much easier. A cuboid's volume is its base area, that's length times width, and then you just multiply by its height. Now look at the cylinder. It's the exact same logic. Its volume is just the area of its circular base, which we know as pi r squared, multiplied by its height. See that connection? It makes these formulas so much easier to remember. Seriously, I'd pause here, maybe take a screenshot or jot these down.
And finally, let's quickly cover surface area. Just think of it like the amount of wrapping paper you'd need to cover a 3D shape. For a cube, it's super simple. You find the area of one square face, which is s squared, and multiply it by 6, because there are 6 faces. The cuboid formula might look a little scary, but it's not. It's just adding up the areas of the front and back, the top and bottom, and the 2 sides. And with that, your 3D toolkit is officially complete. But look, knowing the formulas, that's only half the battle. Now we need to talk about the other equally important half, strategy. How do you actually apply all this knowledge quickly and effectively on test day when you're under pressure?
Okay, let's talk about your game plan for test day. This is key. Before you even think about touching that on-screen calculator, take a split second to visualize what the question is really asking. Then, you activate our #1 strategy, break down those complex shapes. You also have to be flexible. If they give you the area and the length, you've got to be able to instantly work backwards to find the width. And finally, be smart with your time. This is huge. Estimate where you can, and if a question looks like an absolute monster, just flag it and come back to it later. Don't get bogged down.
Whew. Okay, that was a lot of information packed into a short amount of time. So let's do a lightning-fast recap of the absolute non-negotiable must-knows.
All right, if you take away nothing else from this session, please make sure you know these. The area of a circle, pi r squared. The area of a triangle, half base times height. Pythagoras, a squared plus b squared equals c squared for right-angled triangles. The volume of a cuboid, length times width times height. And the volume of a cylinder, pi r squared h. And, most importantly of all, the master strategy. Always, always, always break complex shapes down into simpler parts. If you can master these, you're going to be in a fantastic position.
I really hope this session has helped build your confidence. But the absolute key now is practice. You've got the tools, now you've got to use them. To get your hands on more lessons just like this one, literally thousands of practice questions and full mock tests, I highly recommend you download the EduRev app. It's available on both the Play Store and the iOS App Store. Keep practicing, stay confident, and you are going to do great. Thanks so much for watching.